equation? X squared plus y squared equals radius squared, and then when we want to adjust left, right, up, down, x minus h squared y, right, plus y minus k squared equals radius squared. Does everybody figure, I mean, like in your groups on Tuesday, was everybody okay with that?
Yeah.
Because what's going to happen here is I'm going to give you some circles or some ellipses and ask you to write equations for them quickly with Cartesian and then quickly with parametric. And parametric is new to you, so that's why I want you to make some connections back and forth. So where does the 7.1 here, which was our horizontal shift, where does that show up in their sinusoid equation?
Well, I think it's supposed to be
It really should be here, right?
Yeah.
That should really be 7. Okay. And then what about this 5 here? 4.8. That's pretty darn close. That's not bad. This one's a little ways off, but this one's not bad. And then tell me about the 7.8 and the 7.7. What's that got to do with anything? That's the radius. And so what you're going to see is that the nice thing about parametric is I can give them different radiuses. If the x radius and the y radius are different, then we don't have a circle anymore, right? So that's going to be kind of interesting, and that's coming up. Okay, let's do the next one, and we'll see if we can keep checking these situations. Danny, will you show us yours?
Put mine up there. Mikhail, this is
If you're up here and you notice a mistake, that's no big deal. I would ask you to fix it though before we put them in the hallway. But you don't have to fix it right now. In fact, let's not. Let's talk about, let's listen to what these guys have on this one.
what?
Alright, our equation was x minus 10.5 squared plus y plus 11.34 squared equals 110.
So where was your origin? Danny, will you show us that while he's
It's
writing?
under the paper.
Right there.
Okay, so your center was over how far? 10.5? And down 11 3/4? Okay. And then your radius was? Okay. Is that, so far, do you think they have their Cartesian one okay? Does their Cartesian look all right? All right, let's take a look at the parametric. I want you to take a moment while he's writing and think about, could you predict what the parametric looks like by looking at the Cartesian at this point? Do you know where the center coordinates turn up in the parametric? Maybe you want to just have a piece of scratch paper out and try predicting for them. So x equals, is this x equals or y equals? You know, because the 10.5 showed up, right?
I'll have it. I swear to God, it's not here.
It's not
I swear to God.
I like to have it distinct, but everyone else likes to forget it. Like, except for me. So my friend was like,
It was sticking up.
More words. And then what's in the middle?
Keegan. Keegan.
no, it is just there.
Good question. So to hang on a second, I haven't seen the 2 in there before. Tell me about the period of the graph that you ended up with.
280 degrees.
It did its whole thing at 180 degrees?
This is
It couldn't, right?
This is like because it's like a circle.
Because it's a circle, so it's doing some, the cosine values are going to be different all the way around, and so sine-wise anyway. We might have some that match, I think, cos delta 2, because that would say that, like you said, it didn't do its complete period in 180, did it? All right, thank you very much. We're seeing the same stuff on each of these, hopefully, right? All right, we're going to do something a little different with Mikhail. Did every group get a card?
Yeah.
Okay, you can share. Mikhail's just going to put up his parametric side. Okay, and then I want you at your desk, and you can work together with your group, that's fine. I want you guys to see if you can come up with a Cartesian equation for it, okay? So he's got x, you can write this down somewhere or just look up here. You don't have to write down the parametric. But will you put Mikhail's name so I know when I'm looking at these which one's which? M-C-H-A-L-E. Is that right? I'm going to give you about 2 minutes, and I want you to come up with this side. What's the equation going to look like? Where's the center in this? Where's the parametric? Or where's the radius? You only have to just do one within your group.
So it's the origin plus whatever the radius. The center is in front, and then the radius is
Maybe you don't need even 2 minutes. Are you done? You guys got yours? Got it? Will you rate it? Somebody in your group can agree. We can definitely discuss and make sure everybody does it.
One right there.
Are we ready to find out what it really is?
It's just induction, so you call up everyone's name and you get dress up and stuff.
I kind of like
I said what about score? You didn't do it? Jalen didn't do it?
No, they just do.
Hey, what do you think? Did you get it right? Will you please pay close attention to the pluses and minuses here? Because this is negative 15, this is 15. Because this is negative 13, positive 13, this is negative 13. Remember, because the generic form of it is x minus h and y minus k. These are the opposites of the center. Max, did you have a question?
I thought it was y plus k.
It's y minus in this generic form, yeah? Good, this is good. You figured something out just now.
Hey, good job.
And we can graph it on our graphers. We can do like a table of values. Lots of ways. Do you remember when you first learned this in Algebra 2? Lots of ways to plot point by point by point how this works. But the generic, in fact, let me just. Do you want to jot down the generic form just for the Cartesian? What did we say it was? X minus h squared plus y minus k squared, that's k, equals r squared, where r is the radius. And h and k, what do those represent? Center. The coordinates of the center.
I think I'm sparingly though.
All right, Marie, you want to do yours?
Sure. Why not?
Your whole group. Come on up.
Way to go, Mary.
Oh, hang on. Yeah, good idea. Let's do just the Cartesian first. And then we want to see your graph. So this time on your note cards, we're going to do the parametric. They're going to show you the Cartesian, and you toss out the parametric, exactly. This is a fun game. We could play this all week, couldn't we?
Oh, for sure.
Could we? We could have like lemonade too. Lemonade and cookies don't go together. Lemonade and lemon cake. That would
Alright, these guys are
party.
just going to stand still for a second at your desk with your partners. Will you please put the parametric? The parametric.
Well, I wrote the last one. It's the most precious. Popcorn
Book.
Oh, marker?
Book.
While we're waiting, does anybody else have an urge to make this like a generic rule? We have the generic Cartesian. Do you feel like making a generic parametric right now? I did. I know I
It's
did.
about high five.
Alright, let's take a look at their picture before we go further. Could I have you finish your thought and then be quiet for a second? So, up here, here's their origin. Where's your center?
1.5 is 4.
Oh, I thought that was 15. Did you think that was 15 on the board?
Sorry, I read it.
Oh.
Oh,
No.
that's easy, that's easy. We can fix them.
No. Stupid.
Okay, and then your radius? 10. So that made that 100. All right, Marie, show us your parametric.
Show us the parametrics.
Drum roll. It's a really long jump.
Yeah, you got this.
I like how it's coming from all the way. Well, will you change that X, the top one to X equals?
No, I would.
Oh, God. All right. Thank you so much. Check yours. Do we agree? Did they do it right? Did you do it right? Can we figure out if anybody did make a mistake? You did? How come? You're supposed to go and rest it up over the weekend. Are they matching? Anybody have any questions? Okay. Real quick. Tristan and I both just dying to, as soon as I wrote this, the r squared equals x minus h squared plus y minus k squared. Then he said, I got a little shortcut. I'll just put a rule. So you put that on there.
Yeah, leave her note.
At your desk, will you do the same thing? Guess what he's going to write.
Oh my god.
Do you have a place where you take notes each time we do something new? This would be a good time to put this into your notes.
I haven't started my pre-vote.
Maddie? Okay.
Look to your notes. Where's your notes?
I called it.
Let's put this in it. Do we agree first, before we put it in our notes, we might as well make sure we're sure?
Yeah, I agree.
It's because these, remember, are the opposite of the center. These are just exactly the coordinates of the center.
Tricky.
Okay. Let me give you a minute to write this down somewhere. Hopefully you are convinced at this point that it's true. Have you seen enough examples? Because I got 2 more for you. Real quick, Ashley, you guys want to come up and show yours? Want to grab this one? This is one on the way. You good?
It's right here. Right here.
You good?
Oh my God, they turned this to the sky.
So tall.
Oh my God. It was awesome.
All right, is it okay if I bypass the writing the 2 equations? Let's just look at theirs and see if we agree. Go for it. Shh. Give them your attention, please.